gosh, you know what?
Yeah, sorry about that. There, I'm starting the recording finally.
No worries. You know, I thought, gosh, you know what? It felt like just yesterday that I had fallen into security and founded Fortify Software. And then I realized, oh my God, that's 21 years ago. And so I figured what I would do is tell you some interesting stories about then, and then tell you a little bit about it. So now today I work in venture capital. So I look at companies all the time, and I find it just incredibly fascinating what's changed and what hasn't changed. So I'm just going to tell you all some stories. By all means, if anybody wants to work in a question or you've got a story to tell, feel free to interrupt. I want to make it interactive. And if you don't, at the end, I'm going to force you all to be interactive. So please be interactive. Okay, so first of all, let me give you a little background. And I am nervous because this is being recorded. So I'm going to let you in on a little secret. So I was born in New Mexico, and I moved to Austin about 10 years ago from Nevada. And all of my neighbors, that's all they know. I live in a street where the average tenure is probably 50 years. First thing they ask you is where you're from. And when you say you were born in New Mexico and moved from Nevada, they give you a big hug because you didn't say you came from California or New York. And in between New Mexico and Nevada, I spent about 40 years in the San Francisco Bay Area. And so that will be our little secret. If you meet anybody that lives on Wild Basin Ledge, please don't share that with them. And so I grew up in the Silicon Valley for the most part, and literally grew up while the Silicon Valley grew up. So local kid, went to local college, knew I wanted to build things. So I went to engineering school, and you know, a lot of folks might not realize this, but Silicon Valley is called the Silicon Valley because that's where all the semiconductors were made. At one point, when I was younger, it was about 80% of all the chips on planet Earth were actually made there, designed, made there. And so when I got out of college, or when I was towards the end of school, I, through luck and determination, found myself in a really cool startup. And back then, it weren't companies like Facebook or Google, they were semiconductor companies. So I started my career in the semiconductor world, making semiconductors, and I found that fun. But I always wondered, what are people doing with these things? And so also got real interested in software. And so I went back to college and got a degree in computer engineering and signed up for every software project I could get my hands on. And again, through probably more luck than anything, a little bit of determination, I ended up at Apple Computers, working in the operating systems group, writing software. I was part of the compiler team. I worked on linker loader and some other stuff like that. And that was the first time I really got introduced to security. And I want to tell you guys kind of a funny, my first introduction to security. And so, you know, you're working on an operating system. This would have been the first multi-user operating system that Apple was trying to build. And we got made a part of a project that was IBM and Apple working together. And ironically, that was my first trip to Austin, because there were some folks at IBM working on, back then it was called the Power PC chip, and they were doing that work here, and I came here a couple times. But you know, imagine this big engineering project, probably about 600 engineers, maybe 1,000 people total, and primarily Apple engineering and IBM management and IBM IT. And you know, when you're building an operating system, you kind of have this problem: is you need an operating system to build an operating system. So back then at Apple, we used different types of Unix. So we developed on Unix to build this new operating system. And so when we became a part of this joint project with Apple and IBM, when the IBM IT guys came, they came and explained to us, well, we're not going to let you have the root passwords to your computers. And you know, we explained to them, well, you understand what we do here. We make the operating systems, and so we're the ones that created the notion of a root password. It's like you're not going to do that, and they were real insistent. And for practical purposes, what happens is, you know, you break things in a really bad way, and so you need to be able to reset things and do all sorts of stuff, and you don't want to call the IT department every time you do that. And so that reached loggerheads, and one of our, you know, I don't know if it was one of the management guys or one of the architects decided we're going to have a contest to see who can get the root password from the IT group. And I don't remember the numbers exactly, but it was of 600 engineers total, it was something like 480 signed up to be in the contest. And we had to put together a little system and keep track of everything. And at the end of the first day, I think there was a handful of people that didn't have a root password. It might have been 10, and almost every single one of them had some really good excuse. You know, they had medical emergency or had to leave. The first guys that got it, I still don't know how they did it, but they had it in seconds. I was kind of in the middle of the bell curve. I got it by the IT guys came over to my office and logged into something to fix for me, but what they logged into was something I created that passed on to what they were doing. And that was the first time I'd ever really run into security, you know, as a function. And I thought to myself, wow, that's, you know, really dumb that they didn't really understand what our needs were, and they were really insistent. And yet in the end, they weren't really good at security. So I didn't, oh, and by the way, their root password that they used was the same root password on all their systems. And so again, it was, you know, one of the really key guys that wouldn't ever get fired who changed their root password. And I think 2 weeks later, we gave it back to them. And so my first interaction with security was, wow, you know, I just, you know, glad that's neither here nor there. But remember, I'm at the time a pretty young programmer working on an operating system. And so the irony now, when I look back that, you know, here we were working on an operating system. By the way, our marketing department didn't want to have a login on our multi-user operating system because they felt that was onerous and wasn't natural. You know, it was a big thing with the original Mac user interface that was your desktop. And so you turn it on and there's your desktop and there's files and what have you. And they were like, well, you don't log in to your desktop. We want you to just have your desktop. And we're trying to explain to them, well, if there's multiple users, we don't know who it is. And there's actually a very old Apple patent that's long since expired that I see used all over the place now. We had actually come up with, if you would just use the computer for about 2 minutes, we knew it was you. And it was based on your typing, primarily speed, and which you hit different keys. And problem is, you were in the computer for 2 minutes before we knew, oops, you can't look at that. You're not that person. So security, as it was thought about by the people building the operating system, was this burden. It was a burden that we didn't want to have the users deal with, and it was a burden that we had to deal with. And I think the other thing that's really important from that time, the idea of anybody with really great computer skills doing something wrong or evil, and I don't know if that was, you know, kind of a bubble being a part of Apple, but I think a lot of people who were involved with computers in an earlier time just kind of felt that way. You know, you sort of project yourself on a situation. So everybody you know who makes programs or makes computers are fundamentally nice people, and they like building stuff and what have you. So zero knowledge of hackers or malicious behavior of computers. Fast forward a little bit, I end up asking that same question, which is what are they doing with this stuff? And the .com period was coming along, and so I ended up grabbing a little collection of really great engineers, and we were sort of a fix-it firm. We were a little consulting company, and if you had something that was broken or something you needed built, I'd bring this little rock star team in, and we would build it or fix it, and worked on a lot of neat stuff. eBay helped with the re-architecture of that when it was crashing all the time. But probably the project I spent the most time on was E-Trade, the brokerage system. And this is where I had my second real run-in with security. And actually a third I didn't know about until years later. So I managed the team that built, so E-Trade, like a lot of brokerage systems, there's all this back end systems that get you into the markets and retrieve data and execute trades and all that stuff. In E-Trade's case, it was an old VAX VMS system that was decades old. And then coming up alongside that was going to be a modern architected trade execution platform. And that was being built by a team of really smart folks that had come out of Visa. I had the team that sat on top of that and made the program, the application, if any of you use E-Trade. So all the screens and what they do, the count, the portfolio and all that, but the back end execution is kind of a black box. And so this is pretty early days web programming. So the first version of E-Trade was actually written by a hacker in my parlance. So when I grew up, hacker was a cool thing. It meant you were really good with computers and you could make stuff happen. Like it was just not negative at all. It was a you had to be Steve Wozniak was a hacker, and I don't think he ever broke into anything. Actually, they did do blue boxes, but anyway. So the first version of E-Trade was this big giant C++ program that did everything, kind of screen scraped this VAX VMS, did what it needed to do, and then printed HTML out, and it core dumped, crashed every time that it ran. And so I inherited that, and we moved it over to a kind of like a big multi-tiered Java program, Java and C++ with we were using Tuxedo as a transaction broker, because you need to kind of update the portfolio, update the account, and execute the trade. And if any of that goes bad, you got to roll it back. It's on different systems. It was really awesome, very fun project. One of the things you do on a brokerage system, which remember, I'm kind of coming up the stack. So I made the chips, I made the operating systems. Now I'm actually blown away by what the complexity of these systems, because at every layer, you think of everyone above you as users, right? And the users they're what do they know? And man, the complexity and performance and robustness of a brokerage system really blow your mind. So one of the things we would do every so often, there was a data center in Palo Alto and a data center in Atlanta, and boy, for those of you that are really young, God, the world was so different today. This will all be in Amazon, but back then you had to build out your own data center. And so I think it was 4 times a year we cut the power to the data center in Palo Alto, and thing had to roll over to the data center in Georgia during trading hours. So you do it a few times before that, and we'll plug on that and do that. So anyway, lots of great stuff, moving parts, very carefully constructed, because you just can't be down. It's just unthinkable. And so there was a time during all the middle of that. Actually, I gotta lay the seeds for another security story. So we had a problem that's now just completely handled by the infrastructure, but that is, you've logged into this program, we've got your password, and you know that it's you, and then you're kind of bouncing around this system, and you may end up on different servers for scalability, and that server didn't log you in, so it doesn't know who you are, and we had to create basically a session context, and so I'm there with a brilliant programmer, literally employee number 6 at Apple. He was Woz's understudy, Randy. I won't, this is being recorded, so I won't, let's just call him Randy. And Randy's like, you know what we'll do? We'll take the password. I don't, maybe he used the word encrypt. He said something, and we'll put it in the, I don't remember if we had cookies back then, but it was the URL or something that was a precursor to cookies, and we'll just pass it around. And so plant that one for for later bit of the story. So and famously, what could go wrong? All right, so now you got this big brokerage system. It just can't go down. It's unthinkable. It would be the end of the world. They wouldn't just fire you. They'd literally kill you. And one of the things that allowed that to be is in the middle of the night, systems start firing off tests, and they start running, and they test, 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 and the test pass, until you get to market open, and about 5 minutes before market open, everything's sitting there ready to go, and boom, market open. So you have this, you're queuing up trades in the middle of the night. Back then, we didn't have after hours trading, so that blast of trades in the morning is enormous, and you got to be all prepared for it. And like I said, it never breaks because, in the development world, you're checking stuff in and it's breaking, what have you. But before anything went to production, all those tests ran, and you were very confident that it would break. One night at 3 o'clock in the morning, and pagers, if you don't know what pagers are, watch Breaking Bad. They were things that were used by drug dealers and people that were responsible for computer systems. And so getting all these page things going out, and doctors used them too, getting all these pages going off in the middle of the night, and it's like the tests aren't working. And at first I'm like, that's impossible. So the pager was broken. And I get another pager. Now I'm getting pagers from bosses, and I'm like, oh shit, the tests aren't working. And so we go down there, and by, I don't know, it's like 4:30, we're trying to figure out, what's broken. And again, I just can't impress upon you how impossible this is. And we hadn't really changed anything. And so it is just an absolute impossibility. And so we're poking around, trying to figure it out. And it's kind of like the last really big system that I was a developer on. So I don't even know what it's like today. But back then, in that kind of regulated environment, the people that wrote the programs had no access to the production systems. And it was, they didn't want you to, stealing money or whatever. So we were working in our little world, and the ops guys are working with us. We're double checking that, nothing's changed and everything's the same. And so it's getting uncomfortably close to market open. And we decided, okay, it had to have been the last thing we changed. Let's roll all that back. And it's not as simple as just, go back, do a build. There were some moving parts that had to be done manually. So we're rolling the code back, we're making these changes, and we realized a full build of the system was like 45 minutes. And we only had about maybe an hour before market open. So we weren't going to be able to build it and test it. We were just going to have to build it and make this decision of whether we replaced the thing that was going to, that wasn't working with this new thing that hopefully would. And so we decided, screw it, it's not working. Let's let it rip. And as the build's going and everybody's figuring it out, the security guy, and I totally remember his name, but I'm not going to say it because we're being recorded. He comes in, and it was a relatively small security team back then. I'm sure it's pretty big now. And he's like, "Oh yeah, we put blah blah blah." And to the best of my recollection, I think it was a precursor to an IDS that they put on the network. And so we go run and we tear it out. The ops guys tear it out, and sure enough, the tests start passing. But we've already started updating, so there's massive amounts of servers, and so we're like 10% through updating. So we got to let the update go. And so now we're all sitting there thinking, "Oh my God, this guy has brought down the system," and thankfully he showed up, and we were able to pull his junk out. But we've now updated the system, and the probability, I would say, raw code checked in, clean build, everything updates and doesn't work. It's like I want to say 10 to 1, but this is probably more like 3 to 1 because we're being really careful. So it's basically a 70% probability that we now have broken the system, but we're not going to know until market opens. And so we're there and everything goes. And the worst part is we had about 15 minutes to just sit there and contemplate how screwed up everything was. And market opens and boom, it all starts flowing and everything's going. And we're like, "Oh my God." Everyone just left, including the bosses. And so the security guy didn't get fired then. We all get called back at 3:15, and the way that this person was fired, and the things that were said, and to be honest, I've never gotten looked up and saw what happened, though. Hopefully he went into some other business, was just left this searing thing on my mind. It's like, "Oh my God, I do not ever want to be the security person." Wow. And so as you all know, I'm a security person. So let's talk about that transition. So first thing that happens, and this is while it's right during this time E-Trade, I've got a good friend who is now one of my business partners in Ballistic Ventures, and very smart guy, but not an engineer, not a technical person. And amazingly, though, genius at kind of seeing through technical stuff, even though he doesn't have that background. And so he and I he was a venture capitalist at the time. He was at Symantec in the very early days, and he was the one that convinced Gordon Eubanks that they ought to do this thing called antivirus. He's the one that got Thornton in there and kind of really was fathered that antivirus business. And so he was really fascinated with security. And so he and I would have these lunches. And during the lunches, he would ask me impossible questions. And I would, the nice thing is when you're friends who don't have technical backgrounds, I'm sure all of you do this, is you can give them some BS answer that gets them off your case. But, sometimes that answer wasn't satisfying for you, and you think about it. And so one of the questions he asked me during this period was, what are firewalls made out of? And I'm like, "Well, it's a box, it's metal and plastic, and it's got chips in it." He's like, "No, that's what's the actual logic of the firewall?" I'm like, "What's code?" And he's like, "Why can that code be on the internet, but the operating system, the banking system, the HR system, all of that code can't be?" It's like, what's so magical about that code that it could be over here, and all that other code needs to be behind it? And so here's my buddies asking me security questions. I don't really care about security. And so I give him some nonsense answer. I don't even remember what my answer was, but it pacified him so we could talk about something else. So I get home and I'm like, "Damn, that was a pretty good question. Why, what is it about that?" And so first thing I learned is, wow, hey, firewalls get broken into. And, but generally there's not a lot of code in a firewall, and it's not doing a lot of stuff. And when you get into these other things, they're big and they're complicated. Okay, maybe that was it. And so I start doing research. First thing I find when I'm kind of researching hacking and hackers is a group of guys who later become my friends. John Viego was one of them. Might have been Mark Curfew, who you all probably know was founder of OWASP, but it was definitely John. And they had published this thing. I forget, it was one of the Usenet news groups and security about the idiots at E-Trade that had taken the password. And we didn't do crypto. I learned a new term. We did crapto, and we basically twizzled the bits a little bit and thought, well, no one's going to figure that out. And man, I found that really interesting. And so we fixed that. And the next thing I found, and this is when I got hooked on security. Is everyone familiar with a paper? It's called Smashing the Stack for Fun and Profit. And I don't remember exactly when it was written, but it was probably written just a couple of years before this study that I'm doing. And so it's written by the guy, I don't even know who this person is, but it's Aleph One, who's a hacker, and he's explaining how to do a buffer overflow attack. And it's one thing when you read about that and you're learning about that stuff, it's really cool. It's entirely different when you implemented the linker loader for an operating system. And the freaking users figured out how to break in. And I've had my house broken into, my car broken into at once upon a time, and it's the exact same feeling, but it was even crazier because, I mean, I could wrap my head around somebody breaking a window and unlocking a door and getting in my house. It was like, this user has figured out this thing. So I immediately call 2 or 3 guys that I consider just gods of how operating systems worked. And one of them, they were Apple guys, but one of them was at Microsoft. And at the time he was probably the chief architect of whatever operating system they're working on. I call him, I'm like, hey, do you know about buffer overflows? And he's like, yeah, memory leaks. And yeah, it's terrible. I'm like, oh, no. The users have figured out how to trigger a buffer overflow and take over the computer. And he's like, you're insane. That's stupid. So anyway, don't get very far with him. I call another guy at Apple Computer, and we basically have the exact same conversation. And then I'm like, oh my God, there's like somebody pulled the alarm. There's the world's going to end. And so shortly after that, we created Fortify Software. And I know that's kind of a painfully long story. I hope you guys appreciate some of the anecdotes, but the importance of that story was, I don't think I was that untypical of a computer engineer. I might have been because of the time that I grew up. I got to work on semiconductors, I worked on operating systems, I got to work on the stuff above. So I really had a good understanding of how the machine works. But the idea that humans would try to break it, or that they were smart enough to reverse engineer it, I think a lot of engineers fell into that trap. And sadly, I think they probably do today as well. There's a lot of folks like yourselves that carry that message and try to educate people, but I think a lot of people are still trapped in the same mindset that we were all in. And one of the things that I wanted to share with you all that I was as wrong could be, I felt, and this is probably like 2000, 2001, it was kind of when the internet the bubble was bursting. I thought it was going to be once you made the responsible people who built software aware of this problem, that they were going to want to fix it. And they were going to want to fix it. It was like a perfect storm, right? You've got a clearly identifiable person who's using your creation to do bad, right? That should be a motivator. I think of those scientists that made the atom bomb, so I have become death, destroyer of worlds. It's a real like, oh my God, this is, being used bad. The second one was, it's your creation. They shouldn't be using your creation to do bad. You should make your creation, if they come to jiggle on a doorknob, the doorknob should grab them and take them through a paper shredder or whatever. Like you could do anything you want. And then the third was just, I guess, there was such low hanging fruit. So I thought that the way software security was going to go was that I thought everyone was going to fall in the same mindset that I had, which is this really sucks. I want to do something about it, and off I go. And you got to remember, I was still fairly young. I was mid-30s, and so I didn't have the pressures of deadlines and features offset against doing security right. I wasn't really, didn't own all that stuff, so I didn't see that. But I was just absolutely wrong in terms of the engineering community wanting to own all this. And so, but anyway, we created Fortify, and there's a funny story of Fortify. Y'all probably know who Reed Hastings is because he's a famous was the founder of Netflix, but he was a seed investor, came in and took it over from the founders, built it into this great empire. What you might not know is he's one of the most brilliant debugger computer language guys on earth. He built a product all by himself called Purify, and it caught buffer overflows and not from a memory leak point of view, and built a great company there. So when we first started Fortify, Reed was one of the first people we talked to. We're like, Reed, you had this experience catching buffer overflows. Well, we want to catch buffer overflows and other types of problems that hackers maliciously use. And that's a little bit hard because remember, when you're catching buffer overflows for memory leak problems, if a tree falls in the forest and no one's there to hear it, will it make a sound? Who cares, right? So if a buffer overflow is in your code, but nothing through your execution makes it explode memory, then it doesn't matter. So Reed only needed to find when your memory was being exploded and kind of figure out where those memory allocations were. We, on the other hand, we're looking for the areas where it's not going to be in your execution path. You're going to see it during testing or development. You're only going to see it when some really clever person makes it happen. And so it's a much harder problem. It's not an observation problem. It's a contemplation problem. And so Reed basically says, and I wish I'd listened to him. First of all, what you're doing is impossible. Everyone's probably familiar with the halting problem, and the halting problem is a really elegant statement of a problem that's called the decision problem, and it's an artifact of this thing called the lambda calculus. So the lambda calculus is the structure that all computer programming languages are built from, and the lambda calculus doesn't have closure, which means you really can't prove anything about a computer program. And the halting problem states that you can't even prove that it ever stops, right? So how in the world are you going to prove that it's vulnerable to an attack? So mathematically, scientifically, it's impossible. Engineering wise, you can say, well, with a pretty decent certainty, I think there's a problem here. And so engineers can take that impossible problem and make something that's useful. But Reed was just like, it's mathematically impossible. The proof was actually done long before the first computer was ever built, because it's all based on this abstract math. And he says in parting, I'm so done with that stuff. Why don't you guys just join me and we'll make movies and not make movies, distribute movies to people. He had already had the idea of streaming. And this is back when they were doing DVDs. And so obviously, might have made a few more bucks if we'd gone with him on that. But to be honest, I wouldn't have traded it because myself, my partners, my business partners, we were on a mission, built Fortify. I do remember when OWASP was getting started. Mark Kerfrey's a good friend. Mark's founded a new company called Open Raven. I'm an investor in that company, so I talk to him from time to time. And when the guys were at Foundstone and got started, it was such a great group, and it's an awesome asset to the industry. But a little bit about the history, and then I should talk about the present contrast. So when we started Fortify, we started off with, remember there was pen testing back then. So the guys at Sensic and Mike's team in Canada, in Ottawa, there was a pen testing product. Think about the pen testing products. They were kind of built more by people that were doing hacking, and so it's kind of like very much an outside in. And so let me throw these attacks at the system and see if it breaks. And things were built so poorly that they would break, and they would break so dramatically that you could see from the outside that there was a problem, and then you'd go fix it. But problem with that is, who's going to fix it? Well, it's programmers, and programmers don't speak HTTP protocol, right? So you say, hey, this was sent to something, and this is the response, is completely meaningless to them. And so we were coming at it from the other point of view. It's like, here in your code, there's, you opened a file and you wrote to it, and they said, well, what's the matter with that? Well, you didn't make sure it wasn't the password file, and you're running in a privileged state there, and so that's a real, and the input was given to you by the end user. It's a really bad vulnerability. And so we were trying to be able to look at the code and give to the developer, the findings. And we thought, remember, erroneously, that every developer in the world would be into that, and they would very passionately want to go be engaged against the bad guys. And so we went out. The first version of Fortify was abysmal. We start off with GCC. I just, some of the absolute best compiler people ever on planet Earth, I've asked for that team. And God, tearing apart GCC. And you basically need, compiler reads everything and it builds a syntax tree. And then it runs through the syntax tree and starts generating code. And we wanted to get to the syntax tree to start doing our analytics. And so we figured, well, let's use a compiler, an open source one, GCC, and we'll kind of saw it apart where it creates the syntax tree, and we'll do the analytics. But GCC, probably good for another session, is literally written by a crazy genius, Richard Stallman, and the code is written by a crazy genius. And so, as hard as you can possibly imagine, jamming the analytics in there just to find a buffer overflow and then play around with whether it was reachable or not. And so we got the very, very, very basics. Like, we could find buffer overflows in C code. And we, of course, we're ready for market. So we started to engage the market. I have never, in anything I've ever done in my life, gotten more sympathetic rejection, like all these poor, crazy fools, their idea that you're going to make code secure. No, nobody hacks code. poor dummies. And so, I mean, we went to every, the Apple alumni network is every company in Silicon Valley. And again, I won't name names, but big, successful companies building infrastructure. And, we knew the VPs of engineering, and every single one of them was like, it's just really cool you built this thing, but it's useless, not needed. And so then, fortunately, we hired the sales guy who was really, familiar with banks and the more like the enterprise world. And we started to call on banks, and the turning point that lifted me out of maybe the greatest depression I've ever been in my life. I'm not a depressed person, but I was back then, was Fidelity. And so we go to Fidelity, and I'm using names because they were champion. they were exemplary. So we go to Fidelity, and there's a fella there. Actually ran into him again. Mark, somebody, and he was kind of like a fellow. He had done all this wonderful work there, and was, kind of, a very senior executive level technical person, and do whatever he wants. And so we got a meeting with him. We're explaining what we're doing, and he's listening. And mid-sentence, he just gets up and he leaves the room. And I'm there with one of my co-founders. I'm like, well, what do we do? Like, well, let's just wait, because he didn't say anything. And I mean, it was probably 10 minutes before he came back, and we're getting ready to go. And he's got this guy by the collar of his shirt, and he slams him down. He's like, show them your presentation. And this guy at Fidelity, Jack Yang, shows us this presentation that was like, it was the exact arguments that we were making as why this was important. And he was proposing that they would build some system to do this, whereas ours said, hey, we've actually built this thing fairly. And so that was our first customer. Actually, technically, our first customer were very good friends that worked as CTOs at companies who pitied us and made us customers. But our first real customer that really wanted to do this was Fidelity. And then we met AT&T, and then we met Goldman Sachs and Citibank, and very shortly after that, the Air Force. And so I learned that, okay, there was a place where developers really cared about security. And guess what? They cared because those security teams were awesome, and they worked together, and they didn't, come in and break the brokerage system in the middle of the night and show up late the next day. They were awesome. The security people were awesome. The development people were awesome. And so that's really kind of where we built that business. As all of you know, probably by maybe 2008, 2009, you could walk into just about any company, and they had now had an awareness of the problem. And for what it's worth, application security is where it is today because of security teams. There's a handful of development teams that led the charge, but it was really the security teams that created the awareness. It was things like OWASP and auditors that put pain on people and brought it along. But back then, even we ended up selling Fortify for a fraction of what today's app security companies would be worth to Hewlett Packard, because at the time, Hewlett Packard was the world's largest software testing business, and we had always felt that this is never really going to work until it moves into development. And so security teams and a small handful of people in development had moved application security along, but it really needed to be owned by the people that were writing the code. And we countless presentations where we say, let's pretend we had a car factory and we're building cars. And as we build the cars, there's all these dents getting made in the cars as part of our production process. And then we get out and we ship the cars to the customers who say, whoa, hey, there's all these dents in the car. So we say, great, yeah, ship them back to us, we'll fix the dents. Well, that's what we're doing with software. We're building it, because of our manufacturing process, we're putting all these errors in them, and then we're shipping them to the customers. Here's a crazy idea. Why don't we just build it and look for these things while we build it? And that was our message over and over and over and over and over again. But it still was never really owned by the developer. Or the development groups, and don't get me wrong, there was great exceptions all around the world. My favorite one, maybe it's best to leave it unnamed. There's this building you go into in one of the military organizations, and there's this huge picture over the desk where you sign in, and there's no label on it. It's this beautiful building up in the hills, and it looks like this research campus. And the guy who brought me into that building, said, do you know what that is? I'm like, no idea. So that's a building in Russia where a bunch of smart technical people go to work every day to make the thing that we built not work. And it's the first thing we see when we come in. It's the last thing we see when we leave at night. And that team was all over software security. There was I could probably name 10 or 20 that the dev team was all over software security. And the dev team was the security team. They had melded, but it was real extreme circumstances. So Hewlett Packard but Fortify, we all believed that it was just a matter of time, and this is going to move to development. It's going to be a multi-billion-dollar market. It was probably, I don't know, if you added up all the app security companies in 2010, it might have been $500 million. And of course that didn't happen, right? So first of all, Hewlett Packard kind of went out of the software testing business. The architectures with which we build things changed so radically that their tools were obsolete very quickly, and app security remained, kind of the best practice was a security team that was solid enough in app security to be able to prove to management and development team you really do have problems. And of course, that couldn't be code analysis because it would argue to death that, yes, even though I've built that absolutely wrong, there's just no way in the world that anyone's ever going to be able to access this in this way. And then fast forward, it gets turned into a JSON web service, and voila, you can get to it, but you have these horrific arguments. So the app security teams literally had to hire hackers, break in, show people things are breaking. A lot of you guys would do that for a living. And then you put pain on the development team, and they would reluctantly want to do security because ultimately they want to ship their code and get their bonuses. And so I really turned off to app security myself. I went with some friends and worked in threat detection. People don't care if they've got issues. Well, they care when they're broken into, and I really enjoyed doing that work. But I always kept an eye on app security, and I got involved with a company called Prevoty. One of the products we built at Fortify was, resident in your code, and the theory was, why would I do pen testing when the criminals are going to do that for free, as long as I'm able to observe what they were doing. This is the so-called RASP market. Gartner, by the way, came up with all these terms, SAST and DAST and RASP, and I hated those names, but it's useful. So, found in that period of time, so there's a company called Contrast. They got a fair amount of traction because they were saying, while you test, I will observe, and you can hack on it, and I'll give you better test results. And people had an appetite for that. But the actual, let me go in your code at runtime and monitor things and protect things, you'd just be surprised. I almost use that person's name as E-Trade, but how that person comes to mind, and you're like, I'm not going to let security put anything inside the code. So the RASP market, I think, never really, there's a lot of implementations of it. I think it's ultimately a great way to go. Our idea thinking there was, there's a seminal paper from the early 90s called aspect-oriented programming, where kind of, if you could construct a program, Maurice, you could take care of performance, and I'll take care of business functionality. Kim, you take care of security, and we could all work on those elements of code. Nobody ever came up with a programming language or a framework that really did that, but it gave a lot of people ideas. And so to me, RASP was a way that y'all just built a program, and then this team over here will use this technology to shore it up and monitor it and what have you. I don't think we've got there yet. So last bit of the story, I did with Kate's help, and generosity of our customers, built a pretty nice business at Alien Vault. And after that was over, I was kind of thinking about what to do next. Remember the guy that asked me what firewalls are made out of? He was at a point in his career where he wanted to kind of do the last segment of his career with friends, doing something he really loved, and he loved cybersecurity. And so we put this venture firm together. It's called Ballistic Ventures. Ted Schlein is that friend of mine. Me, Kevin Mandy, probably everyone's familiar with. He's part of the firm. Barmack Mafta, who was my business partner at Alien Vault, Jake Satt, and Derek Smith. And so we now are about 6 months into looking to invest in cybersecurity. So one of the things about venture capital, just to give you guys a little bit of insight there, it's first of all, it's just the biggest privilege in the world to do that job, because I meet every day the most creative, smart, driven and talented people, founders of companies, and some of them are crazy and have crazy ideas, but they're still just amazing people. And so you really get energized. You get to see a lot of stuff. But one of the things that it's easy to remember. So a fund like ours will probably make 14 investments total out of the fund. A big venture fund like where Ted worked at, one of those funds may make 30 investments. And so when you're looking at the market, you're not looking at good companies and bad companies. You're looking for the 14 best opportunities you see. So if we say no to something, you might be the 50th best thing we've ever seen. And of course, we could be wrong, right? We may say no, and you were actually the best. And so it's a little different than people think. And so I've been looking at a lot of app security companies. And our friends at Sneak, and I realized I'm almost out of time. Gosh, I'm so sorry. The people that do program analysis would look at Sneak, and it's a very simplistic, it's a very basic. It's not real sophisticated in its ability to reverse code or analyze things. Absolutely, far and away the most successful app security product. And if we looked at market cap and customer traction, all that. And the first question is why? And so every person I meet who's a founder of something in app security asks, why do you think Sneak is so popular? And most of them have the same answer that I had, which is, I think Sneak was the first thing that broke the barrier that development people feel like it's their baby. And whether it's the ability to customize it or script it, you're kind of using it as your thing to search what you think is important. And I think that blows the market wide open. And so you kind of need pain put on development organizations by security organizations. Once that pain is there, now you've got, well, I want to fix that. And it's funny, I wish more people wanted to fix it for the reason that I did, which I thought Aleph One was kind of a snarky jerk, and I wanted to make things that it couldn't break. But instead, they're making it because the system makes it painful to respond to that. And so I think Sneak's terribly important because it's the indication that things are moving, that development wants their stuff and wants their tools. I think though most development teams are not equipped to build things securely on their own. I just don't think so. So I think it's very important that security teams are part of the equation. They can't be 100%, but they can't be zero either. And so a lot of the products that I'm looking at these days, I haven't made an investment in anything in this space yet, but a lot of them are very much driven by the headlines. And so you see a lot of companies that are software bill of materials, and of course, what was it, the Log4j episode, and just think about the amount of hours that was spent finding it, fixing it. And so there's a lot of people trying to solve that problem, which is good and bad, right? And I think a lot of these things are so myopically focused on an event that they don't take a step back and say, hey, we've got this giant problem with the way things are constructed, and we build a system that can do that better. One of the things that I haven't seen yet, but I want to find, and I frankly, do not have the answer myself, but back when we built Fortify, especially for large banks, what have you, all that code was there. Even if it was third-party code, it was given to the bank, and when they compiled their stuff, we could see all of it. And there wasn't much work in pedigree of the code, but in terms of analytics of what it was doing, it had purview. Fast forward today, and you write a Docker container that's calling all sorts of functions that are provided to you either by AWS or a growing number of cloud-based APIs. It's wrong, right? From a ability to understand what's going on, it's you're really constrained. And so there has to be some way that we could do assurance. I almost said analysis, but it's really assurance that this composite, this system that is my bank. Banks haven't done this, so let's say that's my ride sharing system. That I have visibility of what all I'm depending upon. Some of that transcends security because you have availability. Well, it's availability for security, right? But who all do I depend on for when I make that function call? Is it really going to work? And so something that is able to allow a supply chain to provide assurances to each other as they step down is really important. It's funny. It's really important when you think about it from an engineering point of view. It's not yet from a panic-driven headline point of view, but I think it will pretty soon. So anyway, I realized I took up the whole time. If we're trying to end at 1 o'clock, I can definitely hang out if there's questions. I can give everyone my email address, which is painfully easy to remember. It's Roger, R-O-G-E-R, at ballisticventures.com. If you want to ask me questions, that's the names of the people I couldn't say. There's a couple of my won't share. Anything you want to chat, just let me know. We work pretty much virtual. I'm here in Austin all the time. And if anybody has any question you want to ask now, I can hang out for a
bit. Hey, Roger, you took me down memory lane there.
I asked, was that at all interesting to anybody?
Hello? Hello?
Can you hear us, Roger?
Yeah, we're talking. Hello?
I don't think you can hear us. That's funny. It was a very good presentation, though. I'm sorry, Roger can't hear us right now.
Okay. I'm going to put my email in the chat here.
Yeah.
Make sure I get the typos. There you go. And awesome. Oh gosh, you know what, guys? My fancy Bose system times out after a while. I can hear you now.
Okay. You hear us now, Roger?
Oh my God, I feel so bad. Were people?
Yes, yes, we were trying to talk. Roger, you took me down memory lane with that story. I remember in the 90s, having a Unix admin say, "What, don't you trust your users?" Because Etsy password was in the clear. You could just look at the password. He's like, "Well, we all trust each other." Anyway, great presentation. Thank you.
Oh, I'm so sorry I had that. Yeah, the system, it just turns off after 20 minutes, you know, because we're trying to save it for, I don't know.
It's all good. This has been a great presentation. Great down memory, like Kate said, great trip down memory lane of different things that we've all run into, for especially us, I would say older folk experiences. I know I was heavily involved in some of those areas you actually talked about there, which is kind of interesting. The HP and Fortify, and I was in compilers and stuff like that. You kind of brought stuff that I had done in my history too about that historical things and learning and remembering what the market was like 20 years ago for all those different tools and what the lack thereof that was kind of needed for the development side. Thank you for the time. Does anybody have any specific questions they'd like to ask Roger right now?
Hi, I do. Excellent presentation, Roger. Loved it. One thing I was curious about, and I may have missed it, we didn't seem to discuss like the future too much. Like, I'm not too familiar, but I know about SAST and RASP tools. And from what I know about application security is, sure, they work a lot with the enterprise architecture or the application architecture and that side of things. But me being on the DevOps and cloud side of things, that I mostly interface when it comes to CI. I was just curious. I would love to hear where you think the direction is going based on your experience.
Yeah, thanks, Ryan. So let me kind of start with like what I think it would take to really sort of solve the problem. I think we would just have to completely rethink the way we build software, you know, and like languages and platforms and runtime environments and one of the biggest problems, like if you just try to think about like where do we have security problems, it's where we have flexibility, where content becomes executable, and the program itself can mutate and change itself and all that good stuff. And so the first thing you think about is if things were just locked down so that you didn't have as much variation and flexibility, that would probably be a move in the right direction. Great example would that be, you know, an iPad versus a notebook computer, right? The iPad's pretty well locked down. And I don't think that's the right answer though, because then you'd be curtailing all the creativity to create things. And so I do think as you look at the way, you know, so the trend that we write a little bit of code that calls a whole bunch of other things introduces security because we don't know the trustworthiness of all the things we're but on the other hand, if we did and they were all trustworthy, that would be the move in the right direction. So I would suspect at some point there's a radical re-architecture of things, or maybe not so radical because it may go down the continuum. To the question you had though, I think, and I'll also share with you a funny observation. So, you know, for I don't know, the last 15 years or so, I've been a management guy, more or less, right? And one of the things that I really enjoyed was, you know, seeing the DevOps organization grow and take a major role. And one of the things I did notice though is my ops teams continued to feel like everybody upstream for me is just a nightmare and they're breaking everything. The software teams thinking, you know, I'm ultimately the ones that are, you know, going to make everything fine. And the poor DevOps guys in the middle that probably had the best purview because they saw a little bit of both. But I think I think the ability to have testing in the hands of developers, it's driven by developers, it's them trying to solve a problem, that's separate from testing that's ideally performed in the CI/CD pipeline that pushes things back to development. I think both of those being robust and strong is totally achievable today and very good to do. I'm kind of depressed that products like Checkmarks and Fortify and the others of, that are kind of these big sophisticated systems, that those haven't come down in price and they're more approachable, like a product like SneakCast. But so I do think there's a balance too. I'm still also a real big believer in RASP kinds of technologies, and that's basically, you could almost roll your own, and you think about logging areas of the program that are risky is the first step in doing that, right? So I got visibility of what's happening at runtime. There's a lot of stuff where user behavior can be, the application is great purview to see user behavior, right? And user behaviors tend to baseline pretty well in applications. So if the application itself is looking for bizarre behaviors, everyone's probably seen in code the comment, "This should never happen." Well, okay, if it does, maybe it's the user up to some good. So a little bit there. But yeah, so the future, I think somebody's gonna nail this problem of pedigree in the supply chain, or assurance or trustworthiness. I do think it's not going to be that sophisticated of a solution though. It's probably gonna be, I do something, hand it to you, you do something, hand it to somebody else. And if I'm at the end of that chain, I see evidence that can make me feel comfortable. Homomorphic encryption would be awesome if they could get that working, because then I wouldn't worry so much about data being absconded as it goes up. But anyway, hopefully that helps. There's a little stream of consciousness there.
I agree with the architecture change. Ironically, it introduced a bunch of security issues. But with the old microservices architecture, for this new way of producing apps, like where it's got one key mission, you do this thing, that's it, you pass the butter, basically. And so in one respect, it doing one mission, it seemed that could be make it a little bit more straightforward and a little bit more secure. But with all the HTTP requests going back and forth and all the open ports and whatnot, it a little less so. And and that ties into containerization pretty well. Containerization.
One of the other things that you guys may do and should do is, the more that those microservices are truly immutable at runtime, right? So that and that by the very nature of them, they're going to be hard to mutate, but the programmers being disciplined helps a lot too. The production instances we had in Alien Vault, you couldn't log into them. And why? Because it was impossible. They didn't have any accounts. And, well, what did you do if there were problems? Well, you had to recreate it. And so things like that to really harden and lock things down can make an enormous impact.
But thank you. It does answer my question, and that's a tough one too, for sure.
Thanks.
Predicting the future of.
Yeah, I do love this job, because in my previous jobs, I always felt this pressure that I've got to figure it out. Now I just need to take meetings with really smart people, and they give you ideas at the very least. So.
Like that. Well, thank you.
Thanks again, Roger. I mean, we're about to, actually, I think the Zoom's going to end here in a second. So in a few minutes. So yeah, we need to kind of wrap this up, but thank you for the presentation. And if there's anything else, Roger left his email address in the chat.
Thanks again, Roger. Appreciate you.
And I'll probably join you guys when my friend Teresa Lanowitz presents. So keep me that date, okay?
That'd be fun. That'd be fun. We could get a little dialogue going. That'd be great.
Awesome. Bye, everyone.
Bye, y'all. Thanks for coming this month. Talk to y'all next month. Bye.
Everyone. Cheers.